Hello there. Today we are going to solve another interesting problem. According to Geeks for Geeks, this problem has been appeared in one of the Google interview. So let's look at the problem and see what we can do about it. Okay. So problem is here that given a list S that initially contains a single value 0, that means a list that initial single value is 0. Below are the Q queries of the following types. Okay, so you have a list. That list has first element is 0, and you have some list of queries. Okay, so what is that query means, right? Let's come here. So this is a query looks like. So this is a list of query. So this is one query. The first element of the query 0 means one operation. If it is 1, it means different. So what is that 0 and 1 means? So if you have a query start with 0, that means that that value, which is x, will be added to your list. And if it is 1, what are you going to do? That whatever you have in your list, each of this element you have to do XOR with this 4. So let's look into this sample explanation. So as it says that you have a list, the initial value is 0. This is the first line, right? Okay, it's right here. Okay, you have it. The next, in the first query, in that first query you see that it's 0. That means that 6 will be added into the list. So it has been added. Go to the next query and it is 0 again, start with 0. That means that 3 will be added into that list as well. So 0, 6 and 3. And then the next one is also again started with 0. That means that it has to be added as well. So 0, 6, 3, 2. Now is the interesting fact happen. This query started with 1, meaning that now you have to do XOR with each of this element and 4, such as XOR of 4 and 0 is 4, XOR of 6 and 4 is 2, XOR of 3 and 4 is 7, XOR of 2 and 4 is 6. Okay, so what is an XOR look like? Let's do an example here. So 0 can be represented in binary 0, 0, 0, and then your XOR operator is this. How can you represent 4? 4 can be represented by 1, 0, 0. Now do an XOR. If you do XOR 0 and 0, definitely it means 0. And then take this element and this element, 0 and 0, so makes 0 again. And then take 1 and 0, that means 1. So what is the value of this? Is 4. So that means XOR of 4 and 0 is 4. The similar way, if you do XOR 6 and 4, you'll get 2, 3 and 4 is 7, 4 and 2 is XOR 6. So I think the problem is clear. So now basically to summarize, that you have an empty list, then you add 0 first. That means that initial value of that list is 0. And then you will go to each of this query. If the first element of that query is 0, that means you just add that 6 with the result. If it is 1, then you get a value and XOR with all the elements. Okay, so I have created this list because in the Geeks for Geeks I saw that they use a list. It can be represented as an array as well very easily, but they used a list, so I take it as a list. Now construct the list. Construct list. We will pass the input. And they said that you have n number of queries. We have to pass that n. So what is that n means? Integer n is the number of query. How many query we have here? 3 to 5, right? So 5. All right. So let's do the implementation. Okay. Okay. All right. So first, it has to return a result list. So we'll go with an integer, but in the Geeks for Geeks I saw that they use an array list, so I'm going to use an array list. Okay, so which is cool. So let's create an array list where we will add those data, but before that let's think about it. What can we do? So it sounds like that pretty straightforward approach that you just, whenever you see a query 1, you literally go through all the element of the array and XOR with it. Very straightforward. But the problem is, in that case, the time complexity definitely will be higher, because if you have n number of query started with 1, in that case each time you are going through almost, if 50% the list size is, let's say, n, and you have n number of query, that will give you big of n square, which is not acceptable. So can we do better? What can we do? First, in the brute force approach, it looks like how it looks like in the brute force. Let's do it in that way. You have that list input. What are you gonna do? Okay, so this is the query. I'll say q and then input. Okay, I think we can give a better naming. Let's say queries, right? So here you do queries, you get each of this query. Now what you do is you need a result list, so array list of integer. I will call it result new array list. Okay, and initial element here, as it says, the problem says, is 0. Okay, we are at 0 here. Now we will go to each of this query. So we have the q, right? If the first element q dot get of 0 is equal 0, what we do? We do nothing but result dot add q dot get 1. This is the second value, you just append to the result. Else, if that q dot 0 equal to 1, what is going to happen is that all the elements you have in that result list, you go through each of this element and XOR. So let's say integer val equals to q dot get 1. So you get a value what you will XOR with and go to the each of this element into the list. Okay, so what are you gonna do is integer I equals to 0, I less than result dot size I plus plus. So what do? Get integer, you can say data, and then you'll say result dot get of I. So you get the original value and you can XOR the data and the value. So you can say new data. What will be the new data? Data has to be XOR with that value, so you get a new data. Now you can say result dot set index is I and new data, right? So what we are doing here, we are, whatever the result we have accumulated so far, we are going each of these data and then XOR with that value and update into the list. Pretty straightforward. The only problem is each time you have to do this, the whole number of elements, and you can return the result. Pretty straightforward, right? But this is not what we want. This complexity is big of n square. We want at least better. What can we do? How can we make it better? There is a tricks here. The tricks is that look at from, like, not from the front of the list, from the back. So if you look at the back, if you see that this is an XOR operation, this is an XOR operation, and then you have to do with XOR with this element, right? So if you go from the front, you get this element, this element, this element, and here is an XOR. So look at here, how many times has been XOR for this in this up to this point? One time. You did XOR once with 4. When you see that another one, now you have to go through all those elements again, XOR again. That means number of 1 like you have, that many times XOR will happen. Think about another data as an example, right? So let's say this way. So, right, you have probably 0 1 and then probably 0 2 and then 1 3 and then probably 0 4 and then maybe 1 5, right? So now if you go from this way, you get this element 1, this element 2, now is an XOR. So now what you have to do, you have to do XOR here. Okay, XOR here one time, and then again you have to do XOR here. That's it, up to this point. Now you have come here, this is fine, and then when you come here, you see that 1, you have to XOR all those again. So this second time XOR, and look at here, this XOR will be happen only once. Why? Because before here they were XOR once, but this one was not. XOR did not happen, but here for the last element it will happen XOR once. So this is one time, this is 2 times. But the property of XOR is, let's say A XOR B XOR C is equals to A XOR C XOR B, is the same thing, right? So now if you start from here, let's say first you XOR with 0, so XOR happen, and then when you come here XOR with this, what will happen? XOR will happen once, and then you move forward, you come here. So in that case, how many times XOR will happen? 2 times. Why? Because you already have XOR once, and then with this one, this one you will do XOR. That means already XOR happened twice, and if you do with this XOR here, that means twice and twice. So moving from the front or the back gives the same value, but in this case I don't have to go through the whole list. Only one time iteration should be good enough. So let's do that. All right, in that case I'm going to change this for loop a little bit. What are you going to do is, since we will be come from the behind, so let's say integer I equals to number of n minus 1, and I is greater than equals to 0, I minus minus. Now you get the query, right? So list of integer, get query, queries dot get of I. So you get a queue. Now if that queue is equal to 0, what do? You do nothing, you add that result. But before that you have to have a XOR. Default one, we will start XOR equals to 0, right? Okay, so this is the XOR. When you have a 0, what do? What you do is you have to add that result, but whatever you have the previous XOR, you have to do that operation. So you do that and you say XOR. But the fact is that any number you do XOR with 0, that number stays alive. So that's why initial value XOR is fine. As an example, what is the number binary representation of 2? 0 1 0. Now if you do an XOR with 0 0 0 0, you'll see that result is what? 0 1 0. So same thing. That's why the initial value could be an XOR, which is integer XOR equal to 0. That's good. So each time when you see that it's start with 0, that means we have to add the result, but whatever the XOR we have to update that. Now question is, what happens if it is 1? So if it is 1, you get a value, but in that case that XOR has to be updated. XOR value, because this is what are you gonna do? You don't need to do that. So what is happening here in that example? First you XOR with 5, XOR 0, which is 5, same thing. Now when you come here in this point, in that case you are XORing the previous XOR value 5 with 4, and then you add that result. And when you come here in that case, what happened is that your XOR value is still the same thing, because XOR is not updated. So you come here and you XOR again, and then you come here, XOR with this and add the result, and XOR with this and add the result, right? So sounds good. Let me see what happened, right? So we get the result. Result was an array list of integer. Okay, so we get the result. Let's print it out. Okay, integer I in result. Print. If I print, what I should get. Let's run it. Okay, it's building. Okay, what do you get? 0 3 3 to 7, which is fine. So this first element has been skipped. So what is happening is that end of iteration, all of this element, you have an extra element 0, right? You did not consider. So what you have to do, you will say result dot add XOR with 0. If you do that, okay, fine, just that's it. Let's run it, because XOR with 0 is the same number, right? So look at this. Okay, we don't need that because later on we processed it. It should be fine. Yep. So another options of this problem has been left because your result has to be sorted. So you'll say collections dot sort. We just pass that result. Now if you print 1 2 3 7, is it the expected output? 1 2 3 7. Okay, cool. And then another one is, let's run with this example, 0 2 1 3 0 5. 0 2 1 3 0 5 versus 0 2 1 3 and then 0 5. Okay, so we are not going to use these two. Let's see what happened. And then n is equals to 3, right? Okay, 1 3 5. Yes, this is it. Okay, thank you guys.